Hello everyone, welcome back to alkaline hydroxide 784, and today in the mathematics series we will be doing the hypothesis testing topic, I guess. uh, right, so in hypothesis testing, we need to have a reason for doing it, right? So why do people do it? Well, it's basically when you have a hypothesis, or like you have a bunch of data that and you predicted that this will be the certain mean, and then you need to check how close your data fits to that prediction that you made. So that's the idea of hypothesis testing. So if we go to our previously used idea of making some pipe, the pipe parts, and each in this for this one we are gonna use a diameter of 0.5 centimeters. And if you're the one making the pipes, you would assume that the diameter will have a mean of 0.5 centimeters because you trust your machine and everything. And then you make a whole bunch of pipe parts and then measure the diameters. So your hypothesis in this case will be that the mean of the diameter is 0.5 centimeters. And in hypothesis testing, this is called the null hypothesis, which is which is also known as H0. So the null hypothesis means like it is a hypothesis that there is no there's no result that will discredit whatever that you said earlier, in the sense. So the null hypothesis is that the mean of the diameters of the pipes is 0.5 centimeters. Well, of course, your friend comes and says, hey, what if it's actually not 0.5 centimeters? The data could say otherwise. So this would be the alternative hypothesis. Like it's usually not equals to, but in certain contexts you can have greater than or lesser than 0.5 also. So how do you figure that out? Well, it's based on the question. So sometimes the question will tell you, this person wants to find out if the whatever measurement that they're doing is actually less than this particular perceived value or something like that. So if they say less than that perceived value, then you can say the alternative hypothesis is that the mean is less than this value. And it will be more obvious if the mean of the data is less than the value. But you must read the question carefully so that you can decide between the less than or greater than thing, or like versus the not equals to. If you put the wrong one, then there's a bit of difference in what value you get at the end, and that will cause you quite some trouble. So hopefully when you're doing this subject, I guess, or when you're doing the papers or exams or any question related to hypothesis testing. And yeah, so you need those two hypotheses before you even start. Like you need that to have something to talk about, in the sense. So in our scenario, we will have like the null hypothesis that the mean is 0.5, and the alternative hypothesis that the mean is not equal to 0.5. Okay, so then you collect all of the data, you have all the diameters of the pipes, and from there you calculate a mean and a variance and things like that. That's the population mean, population variance, like the unbiased estimates of the mean and the variance from that sample data, as we saw last time. So using that information, you then find out that the mean that you get from it is 0.48, not 0.5. So is your data proving that the mean of the diameter is not? Well, in this scenario, that's where hypothesis testing comes in. It helps you decide whether your pipes are still majorly 0.5, or whether they've deviated too much from the mean such that your machine is not doing it correctly and you need to recalibrate it. So to figure out just how much just how much is too much or too little, in the sense, like just how much deviation is too much from the mean, Well, we use this thing called the level of significance in hypothesis testing, and the level of significance is usually denoted by alpha. So alpha is like, for example, 5%, 1%, 10%. Yeah, that's the usual one that they will be using. And the smaller the level of significance, the more likely that your your null hypothesis will still be standing strong in the sense, because the level of significance is actually the probability that the null hypothesis can be proved, um, can be said to be wrong when it is still true in the sense, kind of. Yeah, so, oh sorry, not when it is still true, like when it's just a probability that you reject the null hypothesis lah. Like the probability that you find out, get a result saying that the null hypothesis is not correct in the sense. Oh my. Okay. I think it's easier to say H0 compared to null hypothesis. Anyways, that's not the point. So that's the level of significance. So if you have a smaller level of significance, you actually have a better time because you have more range of error to look over. And if you want to look at it in a visual term, if you draw the bell curve, then the level of significance would be like an area under the graph at the end, at the tail of the bell curve. And of course the value of the tail will depend on whether it is not equals to, or is it the greater versus or lesser than kind of situation, which I'll tell you in greater detail. But how it's represented is, for example, if you were to say that the level of significance is 1%, on one tail, okay, let's just stick to one tail first, then the idea is that if you get your GC and if you find out the area of the graph for which there's 1% of all of the data within the standard bell curve. So that's the idea of, that's the area that you get for the 1%. And how you do that is using your GC, because or you can use those tables that they put in the data booklet but no one ever looks at them. Yeah, those tables. And you get a value from that table, which is is it a Z value? Like basically the value that you get from there. So that's like 1% level of significance. So usually they will ask you to test it at 5% or 10% level of significance. So I did mention that there's a difference between the not equals to and the greater than / lesser than situations. For the not equals to, you had to do a two-tailed test, versus for the greater than or lesser than, you do a one-tailed test. So if we start with the one-tailed test, and if I say the level of significance is 1%, then you use a level of significance of 1% when you're calculating it, when you're trying to calculate the probability or whatever it is that you're trying to do. So in this scenario, you would have, like, for example, if you're saying that the mean is 0.5, and since the value that we got was 0.48, we can try to figure out what's the chance of it being less than 0.5, the mean being less than 0.5. So we would then go to the left hand side of the bell curve, and then we will find that area that covers the 1% probability in a sense, and then we will see how much, like what's the probability until the 0.48 mark. So for this scenario, you would be seeing the probability of the values lesser than or equals to 0.48. So in this scenario, if you get a value that is greater than 0.01, then your null hypothesis is still standing strong. But if your value is lesser than 0.01, then your null hypothesis isn't very strong anymore. Your alternative hypothesis will be favored in a sense. So so the idea here is that's why a smaller level of significance actually gives you more chance of keeping your null hypothesis standing, because the area is smaller, so you're less likely to fall within that small area compared to a bigger area by a 5% or 10% level of significance. So yeah, so what happens when you do a two-tailed test? Well, a two-tailed test, when you have the not equals to instead, like maybe you'll be sticking to it, our original scenario, and you say, oh, the alternative hypothesis is that the mean is not equals to 0.48, and our level of significance is still 1. So but instead of using 1 in our area here, we're going to use 0.5% for our area. So what does that mean? It means that we split the 1% into two parts. So one tail will have 0.5, the other tail will have 0.5, and you have to see whether 0.48 falls into either of those tails. But of course, we already know that 0.48 is lesser than 0.5, so we don't need to worry about the greater than area. So we just need to, so when you actually calculate it in your GC, you can just calculate the probability of 0.48 being greater than, lesser than or equals to 0.48, and see whether it falls within the 0.5 area that you find in the graph. So yeah, if that's how it works in a visual sense. So how does it work in a numerical sense? Because you're not going to be drawing the bell curve for each and every hypothesis testing question that you see. So in the from the visual sense, that area that the level of significance covers is called the critical region, and the value that you get from, like, when you drop a vertical down at the end of the area, the numerical value that you get, because usually it's not a standard normal distribution, it will be something like the mean 0.5. Maybe this value is the value that for which the probability of it being less than that value is 0.01, is probably maybe like 0.464 or something. That will be the critical value in this scenario. And there are two ways, and from here we can find out that there's two ways of actually getting our hypothesis testing done, either by looking at the probability or by looking at the value, the critical value. So yeah, before we go there though, let us first see what we must do with the data that we have. So the first thing you need to do is to make sure that you have the data not as normalized as possible. So what does that mean? Like, basically do the stuff that we covered in the last topic, and find the unbiased estimates of the mean and the variance if they are not provided yet. And you also need to state the CLT, the central limit theorem, so that you don't end up, especially if the data is not normal, it's like a bit more, it's like a sampling kind of data, then you must mention it, so that you can assume normal behavior for that data. And once you've done all of that, you can start with your hypothesis testing. You must write down your null hypothesis and your alternative hypothesis, and from there you can then do the test, I suppose. So depending on what your alternative hypothesis is, so maybe let's go with the scenario of the mean being less than 0.5. So what do? You can either use the p-test or the z-test. I think that's how you would say it. So, but usually it's easy enough to use the p-value. So what the p-value is the probability of the, like in this scenario, it's the probability of all of the measurements under or equals to 0.48. So by all of the measurements, I mean like x, for example, just x. Because you're looking at the x bar, because it's sampling, and the mean of x bar is 0.5, in our normal distribution, like our ideal normal distribution curve. So if you're trying to see what's the probability of x bar being less than 0.48, and this will be dependent on your variance actually. So the variance can really change a lot of things. So make sure your variance is correct, and as I said, you must look at it in terms of the sampling chapter. So if, for example, if you have a non-normal data, you must do that whole thing with the so-called, what's that thing called, the population variance squared over n, basically. Sorry, not squared, population variance over n. So from there you can do your p-value finding, in a sense. So the p-value will be the probability of x bar being less than or equals to 0.48, and from there you can just compare it to the critical the level of significance, and see whether the value is greater than or lesser than or whatever. So in this scenario, if the value is lesser than 0.01, then you would favor the alternative hypothesis. If the value is greater than 0.01, you do not favor the alternative hypothesis. Of course, be very careful to not say that, oh, the null hypothesis is definitely correct, because we know that there's still some variance from the mean, as you see in the actual data. We don't see it being exactly 0.5. But what we are truly doing here is just rejecting the alternative. Sorry, not rejecting it, as in, yeah, like kind of like rejecting it. So you're saying you're not favoring the alternative hypothesis in the sense, but that doesn't mean that it isn't exactly true. You know what I mean? Yeah. You're just not favoring it. You're favoring the null hypothesis over the alternative hypothesis. So yeah, but once you find out that it is lesser than 0.01 in our example, then you can go ahead and say, oh, we favor the alternative hypothesis in this scenario. Of course, you don't just say alternative hypothesis, but you mention what that hypothesis is. So in the context of the question, maybe because you're looking at pipe parts and the diameters, you would say, maybe for example, oh, we favor the alternative hypothesis that the diameter of the pipe parts is lesser than 0.5 centimeters. So you must mention everything with the units, the words that are told in the question, all those things, so that your answer is seen in context of the question. Yeah. So do remember to do that. Right, so that's for the p-value. If you're looking at it in terms of the z-value, okay, so the z-value would be well, if it would be like the standardization thing. Usually you end up doing a standardization. So you standardize the entire distribution thing that you have, and then you can calculate the z-value instead of the probability. You use the, like, this is useful if you know the probability beforehand, but you do not know the either the mean or the variance. You're trying to figure out what is the limit to which you can go before your thing is rejected or something like that. Then you can use this to find out using the standardization method. If you don't understand what I mean, like, if instead of asking for the probability of your, the given data, in the sense the data mean, you don't know what the data mean is in this scenario, but you're given the task to figure out what is the highest or the lowest that you can get before the level of significance is reached. Yeah, so in that scenario, I think standardization is quite useful. But if you want to look at if you're doing it the normal way and you want to instead look at the critical value, you can find the critical value for the using the level of significance. Like, say for example, you have 1%, then you find out what's the value that has a p-value that's equals to 0.01. You know what I mean? Like, for x bar lesser than or equals to that value, you will get a probability of 0.01. and then that will be your critical value, and you can compare it to the current value that you have for your the mean of your data. Yeah, so that's how you use your critical value to find out. So make sure that you do that properly. And this is for lesser than. If you're looking at something that's greater than, you must make sure that you must make sure to calculate the the probability of, okay, let's say this time you get a bunch of data that says is 0.51. So for this one, you would say the probability of all, x bar being greater than or equals to 0.51. Instead of looking at lesser than, you look at greater than. So just do it properly lah. Of course, you'll be using a special function on your GC to figure that out, and you must make sure you to know what side of the graph your GC is calculating from. I believe the new GCs have a feature that allow you to do that very easily. The old one always calculated the left side. So if you're doing greater than, then you had to minus off the value that you want. Like for example, in this case, you instead see the probability of it being lesser than 0.51, for which equals to 0.95 in this, 0.99, because so you instead look at the other side of the story, like other side of the probability in a sense. And sometimes you even need to look at the center, and this is for your two-tailed test when you're trying to predict the limit to which your value can go before it becomes this doesn't favor your null hypothesis that much anymore. So how does a two-tailed test work? Basically, for your not equals to, you first have to make sure to divide the level of significance by 2, and based on your value, you can always see where your use the lesser than or greater than, find which side of the tail you're supposed to look at, and you don't need to worry about the other side. Once you figure that out, you can just use the side that it makes sense to use. If your value is 0.48, then you look at lesser than. If your value is 0.51, then you look at greater than. But make sure that the level of significance on either tail will be like half of the overall level of significance. Yeah. And if you're looking at the context of finding the limit of the values that x bar can be, you can use the center, or you can use certain other ways to figure it out, like some kind of arithmetic thing to it. So you can minus this, minus that kind of stuff. Yeah, it's like the probability between x bar to the 0.5 is equals to, yeah, actually you can do it this way. Like you can divide the whole thing into half, like you cut it through the center, and you know that half of it is 0.5, the other half is also 0.5, like the probability, I mean. And if your level of significance is 2%, so you have 1 on each side, 1% on each side, then you can find the value by seeing the area that is 0.49 on this side and then 0.49 on that side, and then you can figure things out and find the value of x. So from this side you can find out, okay, what is the value that will give you 0.01. Then on the other side you can look at 0.99, and then you can find the middle part of it. That works too, I think. So just do it judiciously and understand what you're doing. Like, don't make careless mistakes, because this is a topic which can be very easily, very easy to score in if you understand how to do the topic properly, and if you follow the template of the question answering. Make sure to cover all bases when you're answering the question. And also, don't make careless mistakes. Yeah, that's how you do well in this topic. Don't make careless mistakes. If you do have any troubles with the GC, you can voice it down below. My GC isn't working, so I can't show it to you. Even if I show you my GC, you won't understand anything from it. It's an old model, so if you really want to see a GC tutorial, I would probably try to borrow someone's GC. I do not know. Or maybe if I ever buy a new one, maybe next semester I'll buy a new one. Because I have to do maths again next semester, so I might actually need a GC. If I buy one, then I'll just use that and show it to you. So with that, I hope you found this useful. I do sound a bit confusing because I did an exam today morning and my mind is just in the middle of nowhere. So yeah, I hope you still found this useful. If you have any feedback for the channel, because I noticed there are some people who unsubscribe, although I do believe that it's because the A levels has finished and those subscribers were for JC2 students who didn't see the need to watch me anymore. Okay, I get that, but still it'd be good to get some feedback from y'all to know what I can improve on. And or if you really find this so intolerable that I need to revamp it or anything, you can tell me. I'll try to do something within the limits of my time and my computer. Yeah. So with that, if you if you found this video useful, you can press the like button and subscribe. And I hope your A levels went well. With that, I would like to say thank you and bye.